Oh, press enter. Hello, what's up? I'm not wearing my Nerdist shirt. Are you?
Yeah.
Oh boy, that's embarrassing. I gotta change.
Yeah, you do.
Shoot. Hi everybody, if anybody's here already.
What are you thinking?
Wasn't thinking.
You weren't thinking.
I wasn't thinking.
What about the Nerdist shirt? We have these great shirts made, and Levi just doesn't wear it.
I already lost one shirt, one of the two that I have.
Are you serious?
Yeah, I don't know where it is. I'm sure I'll find it. I haven't gone outside
Why even tell
today.
me that you lost it?
What?
Why tell me that you lost it then if you're sure you're going to find it?
Are you upset about that?
No, I'm not.
Okay.
But I just like...
Your tone of voice sort of demonstrates to me. You're going over matrices.
Yes. And you're going over commas.
Yeah. I'm actually thinking...
Interesting.
Yeah, I'm going to go over... No, you go... Yeah, do matrices.
Yeah, that's a...
Yep.
Interesting proposition you got there.
That's a good point that you made.
Okay, guys. Matrices. The matrix. Are we in the matrix? Are we not? Is everything a simulation? We'll find out after today's stream. Matrices. The plural of matrix. All right. First, we talk about our dimensions. So a matrix is an array of numbers. Let's say we got 1, 2, 4, 3, 5, 7. We got 6 numbers here. The dimensions of this matrix, you want to go in rows by columns. Rows are horizontal, columns are vertical, just like in a building, you got vertical columns. So we have 2 rows and we have 3 columns, so this is a 2 by 3 matrix. All right, 2 by 3 matrix. So what would, I don't know, a 4 by 2 matrix look like? Sounds pretty intriguing. Let's find out. Let's find out. We have 4 rows and 2 columns, so this thing is very tall and thin. And we have 1, 0, 2, 4, -3, 7, 9, 10. 4 rows, 2 columns. That's a 4 by 2. Awesome. We've talked about dimensions. Everybody's into it so far. This is great. The next thing, matrix operations. There's a bunch of things you can do with matrices. First thing, and perhaps the easiest, is called scalar multiplication. So I'm going to put that right here. Multiplication by a scalar. And a scalar multiplication is a number. It's just a number, nice little number, that you multiply every value in the matrix by. So if I did something like 3 times this matrix, we're going to say 1, 2, 3, 4. 3 is the scalar. We're scaling all of these numbers up by 3. Okay? Make them 3 times bigger. We just multiply 3 by every single one of these numbers, and we get a matrix answer. So we're going to have 3, 6, 9, 12. It's that simple. Scalar multiplication. You got it. It's just like distribution, guys. Just like that. You take a number, you spread the love to all the other numbers. It's great. The numbers will thank you for it. Next thing you have is matrix addition, and by the same token, matrix subtraction. Okay? So matrix addition, we're going to put that right here. Matrix addition. Are you going to put on your Nerdist shirt?
Yeah. Are
Very
you going
good.
to?
Am I going to put on your Nerdist shirt?
Yeah.
Well, I don't know where yours is, and neither do you, apparently.
Yeah.
Oh, burn. That is a burn
Bird.
right there. Sorry. Sorry. All right, let's add some matrices. Let's say we have 1, 0, 3, 4, 2, 7. If you're going to add 2 matrices, they have to be of the same dimensions because you're going to be adding corresponding numbers. So if they're not of the same dimensions, you don't have corresponding numbers to match all your numbers, you can't add them. All right? You could try. Not going to work. I would not recommend it. So this is a 2 by 3, and we can only add it with another 2 by 3. So let's say this is 9, 8, 4, 3, 1, 0. The sum will be the same dimensions as our 2 component matrices, and we're going to add all of the corresponding numbers here. So 1 plus 9, top left, 10. 0 plus 8, top middle, 8. 3 plus 4, top right, 7. 4 plus 3 is 7. Sorry. I'm getting confused here. 2 plus 1 is 3. 7 plus 0 is 7. All right, we got 10, 8, 7, 7, 3, 7. Yeah. So this is the sum matrix. It's just corresponding. That's all. So they have to be the same dimensions. Subtraction works exactly the same way. You'll just see a subtraction sign right here, and you will subtract in the order that they're in corresponding numbers. 1 minus 9, negative 8, things like that, okay? So really, if you haven't seen this before, then it might be a little weird at first, but you can realize that these are all very simple things. You've done distribution before. You've done addition. It's just putting them in order and corresponding places and just adding them together. But matrix multiplication that's a toughie. That's a toughie, and it comes up every now and then in the ACT, so you got to be ready for it. So we're going to talk about it. Boop, boop, boop. Very good. Any questions so far, guys? We are here for you. We're not here for ourselves. We are here for you. Levi, how's your day?
My day?
Yes, your day.
My day's been good, a little hectic.
Why?
Just gotta do stuff. Nothing happens for a while, and then everything happens all at once.
Oh, jeez.
Very stressful for everybody.
Oh, my gosh. That sounds pretty stressful.
Yeah.
And you lost your shirt.
Yeah. Pretty horrifying.
Yeah, it's pretty ghastly. Ghastly. There's a T in there. It's like only British people say it. Ghastly. That's how British people talk. I'm always afraid that I'm going to press too hard on this thing and it's just going to shatter. And then you and Brendan are going to hate me. You ever had that fear too? You and Brendan are just going to hate you for shattering the glass?
Yeah.
Good. Good. All right. We are right there. I should probably go a little faster. Matrix multiplication. Is it possible? Is it real? Can I trust it? Can I allow it to take care of my children? Good questions. The answer to many of those is yes. And one of them in particular, like, why would you even ask that question? And the other one is, why would you leave your children with an idea, a mathematical structure? It's just, that's not a person.
Bert?
Yeah.
Matrices.
Matrices.
Yes.
Matrices. Sure, why not? All right. Very good. Let's start with a 2 by 2. Okay. 1, 2, 3, 4 times 4, 3, 2, 1 is equal to. One of the things they might ask you is when matrix products are defined in the first place, which means when you can actually multiply matrices and when you can't. The first thing you want to do is look at your dimensions. I'm going to write them underneath our matrices here. This is a 2 by 2. This is also a 2 by 2. You are only free and clear to multiply if the inner two dimensions match. This number and this number. If the number of columns of the first matrix is equal to the number of rows of the second matrix. If those don't match, you cannot multiply. The product will not be defined. You can't do it. Okay? So that's the first thing. The second thing is that the numbers that you have left, so this 2 and this 2, will give you the dimensions of your resulting product matrix. It will be a 2 by 2. Now all these are 2s, so there's no way to screw up, but later on we'll throw some fun numbers in there. Okay, this is where things get very strange. Here we go. What you're going to be doing is taking pairs of the first matrix and pairs of the second matrix, and you're going to be taking what's called the dot product of those pairs, which means, just bear with me here, the top pair here is 1, 2, and then, so you're going to be working in terms of rows of the first matrix and columns of the second matrix. So we'll start with this. We have 1, 2, we have 4 and 2. What you're going to do, hi all ACT people, Plaster Hippie, you're here! You made it!
Oh, we need to put Plaster, we want to do Plaster Hippie's question.
Ooh, Plaster Hippie's got a question.
Well, no, because remember they put something in the Discord?
I don't remember.
Yesterday, and we didn't get to it.
I wasn't there yesterday.
Oh, gosh, why didn't you remember then?
Plaster Hippie, we'll get to your question today. Don't you worry. Levi's pulling it up right now.
Jace.
So what you're going to do is you're going to multiply 1 and 4, and you're going to multiply 2 and 2, and you're going to add their two products together. All right? 1 times 4, here I'm going to put it in here, 1 times 4, and you're going to add it with 2 times 2. Okay? Pretty wild so far. Let me open this up a little bit. Okay, we're going to make this a little bit bigger. Okay, 1 times 4 plus 2 times 2. All right, when you've finished with that, you're going to stay with the top row here, and you're going to shift over to the right column. So now we're going to be doing 3 and 1. Same thing. We have 1 and 3, and we have 2 and 1. We're going to multiply those pairs and then add them together. 1 times 3 plus 2 times 1. So that's going to be, oh, geez, I need more space. Ugh, okay. All right, let me just, here we go. 1 times 3 plus 2 times 1. Okay? Now, we have exhausted all of our columns of the second matrix, so there's no more we can do with this top row. Now we bump down to the bottom row. We now have 3 and 4. That's what we're dealing with. Now we start back at the first column of the second matrix. So we're now back at 4 and 2. Same thing. 3 times 4 plus 4 times 2. 3 times 4 plus 4 times 2. And then we shift over to the right column here. We have 3 times 3 plus 4 times 1. 3 times 3 plus 4 times 1. All right, now let's add all of this up. So the first one we have 4 plus 4, which is going to be 8. We have 3 plus 2, which is going to be 5. We have 12 plus 8, which is going to be 20. And we have 9 plus 4, which is going to be 13. Okay? I know this seems insane, because it does. Because if you've never seen this before, you probably have no idea what I just did. And it takes a little while for you to start seeing the orders that you do things in. But let me leave you with something before we go into the next one. When we multiply this row with this column, 1, 2, and 4, 2, this is the top row and the left column. The answer, the product of those that you add together, the dot product is what it's called, you don't even remember that, is going to go in the spot that they share. So both of these share the top left corner. Okay, 1, 2, we've got this top corner. 4, 2, we've got the left side. They both share the top left corner, which is why that goes in the top left corner. And then when you move over to this right column, you still have the top, and now you have the right, so they share the top right corner. That's where that goes. You can see where this is going, okay? Let's give you now one more. One more. So before we go to that, let's talk about why these things have to match. 1 and 2. There are 2 numbers here. 4 and 2. There are 2 numbers here. If we had another number down here, there'd be nothing to multiply it with over here. So the number of columns here, which there are 2 of them, has to match the number of rows of the second matrix, of which there are 2. Which is why those inner dimensions have to match. Pretty wild. Okay, let's do one more here. Let's make it a little bit different. We're going to do, here, 4, 5, 6. Dimensions of this. We have 1 row by 3 columns. 1 by 3. Naturally, I have to have something with 3 rows to be able to multiply this by, or else I can't do it. So let's do let's do 6. That was a weird, that was like a goat noise. 6, 2, and we'll do 0, 4, 1, 5. I love making up numbers. That's why I got into this business. 3 by 2. So, can we multiply? Yes, we can, because the 3's match, which leaves us with the outer dimensions 1 times 2. Oh, uh-oh. Well done, JetBlue MC, well done! Ha ha! So the resulting product matrix is going to have these outer dimensions 1 by 2. Put that down. What is that going to look like? 1 row, 2 columns. That's it, huh? Interesting. Well, let's see. We're starting with our very first row, of which there's only 1. That was a fun voice. I know. That's why I do it. I find it fun, too. The kids love that voice. I think of it as like this British headmaster of like some school, like a private school, that's suddenly like rediscovered the joy in his life, and he's really excited to like see all these kids learn because he's been so like stiff for so long.
Like the headmaster in Community, if he were English, sort of. You never saw that. Yeah. Why don't you go watch it? I can finish this.
Okay. I should watch it. I've heard that. Okay, the first row, first column. 4 times 6 is going to be 24 plus 5 times 0, which is just going to be 0, plus 6 times 1. That's going to be on our left side. And then we have our other. After we're done with this column, we've exhausted it, we go to the other column. So we go to 2, 4, and 5. 4 times 2 is 8, plus 5 times 4, which is 20, plus 6 times 5, which is 30. So we're going to add these up now. We're going to get 30 on the left, and then 58 on the right. And that is it. Also, your calculator, if it's a graphing calculator, has matrix functionality programmed into it, so you can input entries for matrices and then multiply them on your calculator. It'll do it for you. That's also pretty fun. Yeah, get some practice.
Also, I made a post on Reddit with that visualization of having the first matrix here and then moving the second one up so that you can come down and hit that other one. I don't know if you want to do that.
Yeah, you know what? Do you want to show them that?
Sure.
Okay, because I need to do that too, and I've forgotten how you set that up.
Yes.
I always use the calculator. Never learned this topic in school. Ah, yes. Yes. When I was young, we asked, like, what if we learn how to do this by hand? Well, can't we just use a calculator? And they always said, well, you're not always going to have a calculator with you in real life. And they were wrong, because now we all have smartphones. But smartphones don't necessarily have matrix capability. But yeah, yes, exactly. And sometimes you don't even see a matrix question. It just comes up sometimes.
Yes, it seems like they're actually moving often in the direction of matrix questions that require you to understand the workings of multiplying matrices.
Multiplication.
Multiplication of matrices in context. So saying, here's this matrix that represents this thing, here's this other one. If you multiply them together, what does this part of the resulting matrix represent? That's harder.
Usually it's like a system of equations.
Matrices
are nice, Stealthy Sumo.
We did not see you get here.
How did you get here so quietly?
That was...
It was
very
stealthy.
sleuth-like.
It was sleuth-like.
Yeah.
It was stealthy.
Sleuth-esque.
Sleuths aren't necessarily stealthy, though.
No.
Well, they're just good at being detectives.
Yeah, unless they're sleuthful
But
youths
I would say,
or youthful sleuths, right?
Youthful sleuths. Stealthy Sumo, are you a youthful sleuth or are you a sleuthful youth? You don't need to answer that.
Yeah, but just think about it.
Just think about it. Have a response in case anyone ever really wants to.
Okay, what am I doing?
Show them your
Matrix?
little...
Okay, and then are you done with matrices then?
Yeah. That's it, man.
Wait.
Yes, we will, Sapien I.
We will go over science tips. That will be after this stuff, probably around, I don't know.
Oh, you know what? As far as interpreting matrices in context, showing how you use them to solve systems of equations, and like, no? Okay.
I just don't...
CB Turtle! We got a lot of people that want that. Okay, yeah, I think we will.
Okay.
I think we will.
If we are going for, let's say, A, B, C, D, E, F, and we're multiplying it by... All right. I posted on Reddit. Could you check that out?
Yeah.
Cool.
Like, upload it?
Sapien I, are you sure you want that? That last one? Yeah.
Nice.
Nah. Yeah, okay. Let's say 2, 3, negative 4. So we're multiplying these two. I don't really want it. Just want to... Yeah, no. That's what I thought, Sapien I. You just... Yeah. It's okay. It's cool. The way... There's a lot of peer pressure. The way I like to set these up to make it visual, I think works super well. So you put the first one here in, I guess, a normal spot. So A, B, C, D, E, F. And then you take the second one and you put it here. 2, 3, negative 4. Ooh, Bird?
Yeah.
The chat needs to be scrolled down for whatever reason.
Oh.
Okay. Setting it up like this, you have to put the second one up top. You can't switch the order, otherwise things get messed up. But what this allows you to do is it shows you exactly how big your matrix is, your resulting matrix is going to be, and you don't have to think about what goes with what because it lines up nicely. So we're going to have two rows here, so it's going to be this size and this size. So it's just going to be these two going across and this one going down, and that's it. Okay? So the resulting matrix here will be we go across this row and down this column to get this row and column piece here. So first row, first column gives us first row, first column here. So we do 2 times, now this is the weird part, 2 times A, 3 times B, negative 4 times, wow, this is going to be way bigger. Unfortunately, it's going to be kind of huge. So this will be a little bigger. It'll be 2A plus 3B minus 4C. That's all one thing. And then the bottom one will be the same thing, so it'll be 2D plus 3E minus 4F. Okay? I like this visualization technique because you don't have to work as hard doing it. Now, this wouldn't work if the multiplication is not supposed to work. Did you talk about when it can't work? Yeah. So what Brady said about it not working is actually taken care of here. So if you're not sure if it's going to work or not, set it up and start doing it. Because if we are trying to multiply these two matrices together, just this one, and then we'll cut it off there. We're going to try to do this, so it'll be a 2 by 1 here. So we'll do 3A plus or minus 4B, bam, bam. But then we have C, and it doesn't have a buddy here, so it doesn't work. If you are going through and you don't have pairs all the way through, this doesn't work. So you can't do that multiplication. So it just shows it to you. Does anybody have any questions on that? Otherwise, I can move over to commas next, and then we'll get to this. I would like to do Plaster Hippie's question real quick because I think it's interesting. Plaster Hippie, number 39. This is in the Discord, so if anybody's new, check out the Discord. Plaster Hippie's question is there. Plaster Hippie, I want to make sure if you still have this in your life somewhere close by, if the answer to number 38 is the colon. I think it should be. I think this is a tough one. Hey, Bert, can you check the Discord question?
Yeah.
That Plaster Hippie posted? C is lonely. Yes, C is very lonely, Stealthy Sumo. Very, very lonely. Seems as though nobody has questions on that. Which is ideal.
Oh, just fresh octopus. Wait, 38 or 39?
Well, 38 is important to at least understand before doing 39. Plaster Hippie wants number 39 done. But
Yeah.
so I think 38 is colon with.
Oh, okay. I'll look at 38.
Yeah. It can't be a semicolon, it can't be a period because there's no verb. And then I forget what the other option was. I don't love starting the thing after the colon with. It seems a little...
There's no colon. There's no with after the colon.
But then it's misleading.
No, not necessarily. The variety of seafood, colon. They give you a list of seafood.
But I would want a comma there, just because it's saying, like, a variety of seafood with these things, so it's...
Well, remember, the with is taken out if you use the colon.
Oh, you can just do a colon, there's no with?
Yeah, the with is underlined.
Then we don't need with. So I think that's right. Yeah, this is way better. I don't like the... Okay, so anyway, yeah, it should be a colon. Great. So anyone would be and if that's confusing to you, let me know. Anyone would be overwhelmed by the variety alone. Live blue crabs, half-ton swordfish, 20-pound tuna fillets, and something else. Number 39 is asking you what goes best in this list of things. And I'm going to check. Can you read the first answer to me? What's there?
It's no change. It's just fresh octopus.
So fresh octopus is one option. What's the next one?
Some other slightly more exotic species.
Slightly more exotic species.
Yep. Then
What's
we
the next
have, something that I think was octopus.
Something that I think was octopus.
Then just etc.
So Plaster Hippie, what was your original answer here? You put etc. Okay, not a bad choice. We do have a list of things. I would get rid of fresh octopus. Or, well, we are trying to fit these in with exactly what the question was.
Wait. You don't get rid of fresh octopus.
Sorry? Yeah, I think we do. So it maintains the descriptive pattern. That's what we want. So I'm going to write that here. Maintain descriptive pattern. This is more of a judgment call than anything else. Maintaining this descriptive pattern. What is the pattern here? So we have live blue crabs, half-ton swordfish, 20-pound tuna fillets. The descriptive pattern here is crazy stuff that we never see. Live blue crabs, that's awesome. Half-ton swordfish, that's awesome. 20-pound tuna fillets, that's awesome. Kind of. That seems like what they're going for. So, etc. doesn't maintain that descriptive pattern. Because etc. is not descriptive at all. And these are very descriptive. So that's why I would get rid of etc. It does work grammatically, but that's not the question here. Can you scroll down? I can't see these last comments.
Yeah.
Sorry. Okay, so Sun 4H. Yes, there you go. Thank you for that, Plaster Hippie. Now, some other slightly exotic species. I don't like this word here, slightly, because it's not like these things. We have live blue crabs, half-ton, 20-pound, and then we have slightly, which isn't in the same descriptive pattern. I would argue that. So I don't like slightly, so I don't like B. And it's vague here. Now, fresh octopus. Sure, there's octopus, and we might want to talk about octopus, but fresh isn't that exciting. Okay, it's a fresh octopus. I don't necessarily even know what that means. Like, was it recently caught and, put in? I don't know what that means.
That's the answer.
Are you sure?
Yeah.
Did you look at the answer key? I'm pretty sure the answer is C.
It's adjective noun. That's the pattern.
Can you scroll down again? I don't know what the issue is. It's still not working. A is correct. Adjective noun pattern. Okay. So A is the right answer. I actually like C more because it's something that I think was octopus, which is more of the descriptive pattern of like, this is amazing and I have no idea what this thing is. Actually, that's what I would have put. Fresh octopus works, but it is descriptive. Etc. is not descriptive, so that's the problem with D. I really don't like A.
Well, the pattern is just adjective noun.
Yeah.
Live blue crabs, adjective noun, half-ton swordfish, 20-pound. It's just a description and then a noun.
Yeah, I don't like this at all, to be honest. Yeah, the descriptive pattern, I interpreted that as the contextual descriptive part of it, so how it kind of felt, and I like the feel of C. Hey, Storm, how are you? What is wrong? Can you, yeah, okay. So we got this. Plaster Hippie, do you have any questions on this? Rules more like guidelines. Very nice, Stealthy Sumo. Brady, can you actually erase this? I'm going to try something to fix the chat.
Yeah.
And then I will do commas.
Okay. I should make noises.
Yes, make noises.
Ah. Oh, so we can't see their previous chats. That's okay. Is science on right now? Actually, Levi's about to do commas. I mean, Levi, if like 4 or 5 of them want to do science right now, should we just do that first?
Yeah, I'm happy to do science. That's fine.
Okay. You want to pull? Yeah, we'll do science right now. You want to pull up an overlay?
Yes. We might lag. Oh, I'm going to go backwards.
So does English seem to be mostly patterns? There are certain questions that ask you about maintaining patterns, but a lot of English is about grammar. It's about what punctuation mark works here. It's about identifying independent and dependent clauses. It's about subject-verb agreement. I mean, I guess you could say that the language itself is understanding patterns. Like when you conjugate verbs, there's a pattern. You don't say I is. We say I am. Storm, it all depends on what scores you're getting right now. Figure out what your weakest topics are and decide, have you taken a practice test before? You should try to do that if you can and identify what your weak points are. You don't have a lot of time left before the ACT, but if you can do like a section, maybe 2 sections a night, or maybe half a section each. Yeah, we'll talk about science though right now. Okay, so is our Wacom tablet working?
No.
No. Okay.
I can move around for you if you want to explain.
Yeah.
something.
Can you scroll down? Let's go to a different passage.
Okay.
The deal with science is that it gives you so much information, and you don't have time to read most of it. You could try reading all of it. You could try really understanding these experiments, but then you'll run out of time, and you'll only be halfway through the test, which is just, it's not fair. So what your goal should be here is, instead of going to, let's go to a question. Let's go passage. That's good right there. Yeah, we'll start right there. Instead of reading everything first, what you should be doing is going straight to the questions, and the wording in the questions tells you where to look. Okay, so we'll start with number 15. According to figure 2, the solar radiation intensity 8,000 years ago is closest to which of the following? So you're not supposed to know previous information here. There's very few questions, maybe 3 or 4, that require a little previous science knowledge. We'll talk about what kind of things that might be. But most of it is just reading graphs and things like that. So let's try to identify what are the most important parts of this question that will tell us where to look. That's question 20, I think. We're going to do number 15 real quick, though. So according to figure 2, right there, that tells us we're looking at figure 2 for this. You don't have to look elsewhere. They tell you where to look right here. The next thing, solar radiation intensity, okay? I kind of know what that would probably mean, but I don't know what it means in the context of the experiment, but let's keep that in mind. Let's put that over here. They're asking for solar radiation intensity 8,000 years ago, so that's a date they give us. And they're asking what's closest to which of the following. All right, solar radiation intensity 8,000 years ago according to figure 2. Let's go back to figure 2 now, which we will in a second, and let's see if we can find where that is. Okay. Figure 2. Here we are. This is figure 2. So let's take a look at what we have on the graph. We have thousands of years ago. Interesting. We have 2 different y-axes. Okay. Be careful here. We're only asking about solar radiation intensity, which is on the left axis, not concentration of CH4, which is on the right axis. And you'll see a key as well. So we're looking at the dotted line. The dotted line is right here, and we read it to the left because that's where the y-axis is right there. So we're asking 8,000 years ago. Where would that fit on our graph? This is a time. Time is on the bottom. Thousands of years ago, we want to go to 8,000 years ago. So we have 5, 6, 7, 8. Right here, this is the right time. And now we just go upward. We're looking like it's right around here. If we now bring it to the left to read it, it's a little low. It's around 500. It's around 500. Let's take a look at answers. Levi, can you bring us forward? Number 15. Do we have 500? We have something very close to 500.
No,
we have a
500.
couple answers that are very close.
C is 500.
C is 500, right. Let me just make sure. Let's go back for a quick sec. 505 and 495. Yes, okay. These are very spaced out increments. So 495 is way too low. 505 is way too high. It's right around 500. All right. So that kind of question right there is kind of the easiest it gets. But as you can see, I didn't have to know any previous information about what's going on in this passage to get that. All right. Let's see if there's more questions like that. So let's see. 18. Based on figure 1, the average solar radiation intensity over the past 250,000 years was closest to which of the following? K or Meyer, I'll put you right in the queue for right now. Okay, so figure 1, average, past 250,000 years. Those are kind of the important parts. Levi, can you bring us up to figure 1?
Yes. Yep.
Okay, one more.
Oh, sorry, I got you.
There's figure 1. Fantastic.
What do you want on the bottom there?
Let's see.
Thousands of years.
Well, yeah, we'll talk about that. So thousands of years. So they asked us for the average over the past 250,000 years. So that's over this entire duration of this graph, from 0 all the way to 250,000 years ago. All right, and then go back so we can see the top of the graph. And what they're asking for is the average solar radiation intensity. So we're looking at the left y-axis, and we're also looking at the dotted line. The dotted line is fluctuating. It's going up and down, up and down. If we had to ballpark an average, what would that be? This is almost reminding me of a sine wave, and what you're looking for is the midline. Where is it kind of return to every time after it goes up and down? And it looks like it's, between the peaks and the valleys. You're looking at something along maybe these lines a little bit. So what are we close to? Well, make sure not to look at the right side because that's the wrong y-axis. We're close to around 480. Let's see if that's an option. Levi, let's go to the answers. Okay. We're going up to 14. There we go. 480, right there. H, right above our little bar there.
Yeah. It's right here. 18 is the top right now.
Oh, it's the same one.
Yep.
Oh, geez, this is embarrassing. I am so embarrassed.
For you.
Do you do the straight data questions first? Good question. Good question. Here's what you do first. You look at your passages. There's going to be one passage that's called the conflicting viewpoints passage. All right, there's going to be 6 passages. One of them is conflicting viewpoints, and that's where scientists or students are arguing over some phenomenon, and they're giving their hypothesis for what's happening. You'll recognize it because all the paragraphs will be labeled with like scientist 1, scientist 2, or student 1, student 2, and there will also be very few pictures. Now, they won't be like graphs like all the other ones. You want to leave that one last because
Don't read that. It's fine.
yeah, you want to leave that one last because that's going to take the longest time. And it's always random what order these passages are in. So sometimes that's going to come up the very first passage, other times it'll be later. When you get to it, skip it. Make sure you're at the right part of your Scantron so you don't, fill in the wrong bubbles. But skip that. Come back to it if you have time because that will take you the longest. There's a lot of reading involved. The other passages do not involve the same amount of reading. Okay?
Yes, unless you hate the research summaries like I do. I like doing the conflicting viewpoints in the middle. So data summary and then, or data representation and then conflicting viewpoints because I know where everything is.
Yeah. Yeah.
But whatever you're into, whatever gets you going. Yeah.
So yeah, you're more of a reader, you're saying?
Me?
Yeah.
Yes. Yeah.
Most students I've worked with, I think it takes them, even if they like conflicting viewpoints more, it takes them longer to do anyway. So try this out, see what you think of them. But I would say that for most students, leaving that till the end is the right call. If you have a lot of experience with it, yeah, exactly, but it does take longer. Right. Okay, so skipping that is one thing we want to talk about, if that's, which for most of you is going to be your thing. Yeah, exactly. So what you do for the rest of them is just question by question, look at them, figure out what those keywords are that'll tell you where to go, follow those. There will be times when there's a word you don't understand. It's not because they expect you to understand. Thanks for the follow, Kyer Mayer, Oscar Mayer Wiener. That's not what your name is, sorry. But it'll be defined somewhere, right? All of the crazy scientific terms are defined up in the top paragraph. We're not telling you to read that top paragraph, only when you have to. Levi has this phrase, read what you need, okay?
Do I?
Yeah, of course.
I've never said that.
You're right. You say follow the path.
Yeah.
I'm sorry. Read what you need is from something else. Levi's phrase is follow the path. It's when you look at where, the key terms and you let them guide you where to look, okay? Do not do this for the very first time this coming Saturday. Try this out, okay? See what this is like. See how many you can do. And how fast you can move through this thing without reading. Because, trust me, by reading all this information, you're going to bore yourself to death. It's going to be confusing, and you're not going to get through half the test. It's just not worth it. Let's try another one. Number 16. According to Figure 2, if the trend in the CH4 concentration had continued to match the trend in the solar radiation intensity, the CH4 concentration at present most likely would be what? At present. Okay, so we're looking at Figure 2. We're looking at the trends between CH4 and solar radiation intensity and thinking what the CH4 concentration would be at the present. Let's look at Figure 2. Levi, bring us up. Okay, Figure 2 is right here. So as we can see, CH4 concentration is the solid line. It stops chilling with the solar radiation line around 5,000 years ago and starts going up this way. Okay, so it's saying if it had not done that, if it had continued its trend, which is following the solar radiation, where would it be today? Well, we would just imagine it, it goes up and down a little bit, but it would still pretty much track this line right here, which would mean it's going to be around here at the present day, because 0 thousands of years ago is today, and they're asking for the concentration. It's going to be on the right axis here, around 450. Let's see if that's the answer. Levi. 450. Okay, we don't have 450, but we have is less than 550. This kind of question's identifying the trend of the line, and because you're inserting your own prediction into it, they can't actually ask you for precise answers. You can have a pretty general sense of where the line's going, and they're gonna honor that by giving you large ranges of answers. So if we thought it was gonna be around 450, that's less than 550, and that's the best we can do. 450 would be way less than that. Everything else would assume that our CH4 line would go higher and higher. So I've already done 18, 15, and 16 without looking at the passage, besides the figures and graphs that they're telling me to look at. Okay? Not all questions can be answered this way, but a lot of them can. A lot of them can. Okay? And like any other section, if there are certain questions that you just don't get, it's not worth your time. Sometimes terminology gets confusing. Yes, it does. They will define the terminology for you. Exactly. So you want to, if you don't know what something means, chances are they define it somewhere. You might have to figure out what that thing means, so search around for that word. Just don't read everything, you need background science knowledge, I think.
Yes.
A couple of them. Yes.
Yeah, okay, so this is what I wanted to talk about, Bob Jamaru, because we were talking on Discord for a bit. The approach that I think will help you, because you get it, you understand logic, of course your brain works, but it's about when to do different things. The general approach is following the path, and the question is the hardest part of the science section. Every question is the hardest part. The answers are pretty simple, generally. When you get to something like 20, there's a little bit more going on. But you want to, every single term in the question is important. So don't try to understand the question until you understand every term in the question. So according to figure 2, you obviously know what figure 2 is. Just go to that, that's where you'll be. You need solar radiation intensity. You're going to look for that. The best places to look are the labels for whatever lines or bars that are on the graph, the axes of the graph, and that's where Brady found them. And then you're looking for 8,000 years ago. So you look for that number or numbers that are enclosing that number, something like that. Every single thing has to be defined. Define every part of your question, and the answers are generally pretty straightforward. There exists a path, and you just need to identify it, if that makes sense. So you are trying to, so what Brady did, Brady, I think this is what you did. You went to figure 2.
Yep.
Then you found solar radiation, you found 8,000 years ago, and you found what it's closest to which of the following numbers. Now, this is the simplest one, but that approach has to work for every single other thing. And this also helps you with outside knowledge stuff, because if you can't find that thing, then you've hit a dead end, right? If they say, I want A, but there's no A in the passage at all, then you have to find a way to connect A to B in the passage, because, as we were talking on Discord, it's ozone layer and ultraviolet rays, right? If you don't know the connection there, then yeah, you're cooked. But if you do, it's using that approach to identify what connection you need to make, and that'll get you as close as possible before needing to actually have that outside knowledge.
Can we talk outside knowledge?
Yeah, we can talk outside knowledge. I'll turn this off for you.
Okay, so for the most part, the science section does not ask you about your previous science knowledge, but there's a couple of questions that will require it. It's kind of what separates the men from the boys, to use that expression, for the science section. Because a lot of people can read graphs. Does everyone know what the constituent parts of photosynthesis are? What's on the left side, what's on the right side of that reaction? Things like that. So, kinetic theory of gases. Exactly, yes. And for that one, you need to understand what the basic premises are of kinetic theory of gases. Now, that's like one question. Most of the rest of those questions you can answer by looking at the passage. That was a conflicting viewpoints one and a particularly tough one, if I remember. All right, so some things that you need to know for background science knowledge. You need to understand the Celsius temperature scale, which is what we use for science. We don't use Fahrenheit because it's a ridiculously designed system. The Celsius temperature scale. 0 degrees is freezing for water. 100 degrees is boiling point of water. Okay, so we got freezing. We got boiling. Okay, they assume that you know this. This is Celsius. Great. Next thing you need to know is pH scale. Okay, the pH scale measures how acidic or basic something is. It goes from 0 to 14. In the middle is 7. 7 is neutral. 7 is not an acid or a base, neither an acid nor a base. And water is an example of a neutral chemical. Yes, Kelvin, they'll give you sometimes graphs that have Kelvin on the temperature scale, but what you need to know for as far as actual numbers go, you don't need to know the freezing point and boiling point of water in Kelvin. You need to know it in Celsius. They don't need you to convert anything. Don't worry. So yeah, 7 is neutral, water is neutral. 0 to 7, this is the acidic part. So if you're less than 7, you're an acid. If you're greater than 7, you're a base. Okay? I think of it, A comes before B in the alphabet. Earlier numbers are A, acid. Later numbers are basic. Okay? That's the pH scale. Next thing that you should know is the difference between an independent and a dependent variable, because that will definitely help you out on some of these, conceptually as well. Even if the question's not what was the independent variable, understanding how experiments are structured will help you out a lot.
Temperature.
Temperature.
Just take the top right to write these things for you.
Yes.
What's your next thing?
pH. Talk about pH.
Yeah, oh, pH.
Independent versus dependent variables. Okay. So, in an experiment, you are trying to figure out the relationship between some variable and some other variable. We got new messages for some reason. It's not scrolling. You're adjusting something, and you're seeing what effect it has on something else. Okay, so there's two variables involved. Let's say there's a very simple experiment. Let's see. How could you walk through? Wait, Levi, can you can you scroll down in the chat?
Yeah, I thought it did. Sorry. Is it down?
It's it still says new messages on the bottom, and it's blocking someone's message. Sorry, guys, we're having a little trouble with our chat. I'm going to keep talking, though. Let's say, there we go. Okay. The science scale questions. The science scale questions. Mojo123, can you tell me what you mean by that? The science, do you know what he's talking about?
Nope.
Like how they graded, the grading scale of the science section? Let us know if you can find one on the ACT we have posted below. Let's say that we're doing an experiment that is on the amount of water that you put in plants. What the effect is of watering on plants. But doing it myself. So, I do much worse. I can explain ACT passage to someone else, but doing it myself. So just gotta explain it to yourself, and then you yourself will understand it better. That helps at all. If we have a couple of pots of flowers. We got flowers, great. I am not here to be a great artist. Nothing in the world looks like this, except for my flowers. And we're putting different amounts of water in them. So let me put some blue in here. Okay, we got more water, we got a lot of water. Okay, the thing that the scientists are changing is the amount of water. That's the independent variable. I know you might think independent means it stands alone. It kind of does. It doesn't depend on anything else. The scientists themselves are changing the independent variable. And then what they're measuring in response to that is a dependent variable. In which case, I guess what they'd be measuring is maybe the height of the plant. So let me make this one. Let me make this one a lot higher. Woo. Okay. Scales and balances. Oh, okay. Like what they actually are. Well, a scale and a balance is just a device used to measure the mass of something. Is that what you're talking about? You might need to know some metric prefixes, but I think for balances and scales, those are just, they used to call them balances. Well, they still call them balances, but they're no longer like the teeter-totter looking things.
I think it's questions like, we should probably just put this in the queue. But if you have like, here's a little scale thing, and it has a little table here, and you put something on it, and so it reads 5 kilograms. But then, you know, let's say that thing is another scale that's just put on top of it or something, like that. So you have two scales, and they're both going to read 5 kilograms if this scale weighs 5 kilograms, given that gravity's going this way, right? And we're on Earth normally, because you have opposite things going at the same time. So you're so much better at science than I am, but equal, opposite, whatever stuff.
Yeah.
You want to explain the concept here, like that type of thing where gravity's going and all that?
So wait, what's going on here?
So if this scale reads 5,
yeah,
and it's holding this scale on top, and this scale's upside down. So this scale is also, because there's no movement going on, they're pressing each other with the same amount of force, and the scales are reading force or mass or whatever.
Yeah.
So this one will also read 5. It will be an upside down 5, but whatever. So they'll both.
I have never seen a question where they put a scale on top of a scale.
It's cool. There's definitely one in one of the more recent ACT practice test books.
Okay.
It's cool, though. I like it.
Yeah.
And then let's say that you have another scale here that's on top of it. Then what's going to happen is... You want to explain this? If we have this guy's going to read 0 because there's nothing on top of that.
Yeah.
But these two are both on top of this one, so this is going to be a 10. And then the middle one is... I actually don't know. I assume it's going to be 10, right? Well, being pressed down by that one.
They have scales on top of each other and look like clocks.
I've seen that one. Also, what you're dealing with there is because it's turning over, then the clock would be going instead of, if it reads this way here, and this is 5, then when you flip it over and it's reading 5, it's going to be going that way? Huh? Something like that.
Okay. Oh, this is really interesting. Okay, so if we can just go back to the one before.
We also need to get to these other Q questions.
Yeah.
So, quickly, I guess.
I'm not sure, the fact that you're asking a specific question about this means that it probably won't show up on this, this question might come up every 3 ACTs or something like that. So I think in general, it's probably better for you to focus on your strategy and practice rather than understanding the scale question really, really intimately. And part of that is me saying, I've never seen this before, so I'm not exactly sure if they're asking what the readout would be on all these scales.
Yeah, there's been questions like that.
Which is kind of a tough physics thing. This bottom one would have the mass of the scales above it. This one here, the mass of the base of this thing is pushing down. So that's what it's reading if we don't have this part.
Right, so you have the mass of both of them pushing down. So it should be 10, 10, and 0 on top.
I don't think... okay, so we have this first one here. This says 5. If this one's upside down... Okay... this is kind of hard to draw. It doesn't care that it's on top of something. This is to this thing. It's the same as it being on the ground.
Yeah, yeah.
So it's going to read however much this base, however heavy that base is, pushing down.
We're saying it's 5.
If the base is 5, yeah.
They both read 5.
Then they'll both read 5. 0, 10, 10. Yeah. Okay. So when you put this on, it's got the 5 above it, and it's also the 5 of itself. So it's upside down. Yeah, 0, 10, 10. That does make sense. Huh, I've never seen that before. Does that make sense? This is for Mojo 1, 2, 3. So it would be 0, 10, 10. Again, though, this is going to be one question out of 40. There's no way they're going to ask more than one question about this. Okay, so independent variable is the thing that you yourself change, like the amount of water. And they're always really nice numbers. So you might have 5 mils, 10 mils, and 15 mils. The scientists choose nice numbers because it's, why would you not? The dependent variable is the thing that you measure that changes in response. So the height of the plant. And this will be numbers that are very strange and not nice because they're just numbers that happen in the situation. This thing grows 3.23 centimeters. The chances of something growing exactly 3.00 centimeters is very slim. Chances are it's going to be some kind of a decimal. That's all I'm saying. It's another way that you can identify dependent variables. These are going to be numbers that aren't perfect numbers, so to speak. And this is 10.62 centimeters, so that's awesome. This one is 4.2 centimeters. So clearly there's some ideal amount of water that's not too much. It's kind of like Goldilocks. Yeah, okay, so we talked about independent, dependent variables. And there are always other things that pop up sometimes in science. Levi, do you want to do FIFA 123's question?
Yeah, I'll do FIFA 1, 2 trace, whatever.
Okay. Best thing I can say for you guys, though, is do some practice. Print out a section. Try this. Try going to the questions first and letting them guide you. Okay? See what that feels like. You're going to get through a lot faster.
Yeah, this is for everybody but Bob Jammer because we were talking about it. Define everything. You have to define everything, and you follow the path from the question back to the passage, and then you may hit a dead end. If you hit a dead end, that's fine. Go back to another term in the question. Go until you hit a dead end or you are able to connect with the previous thing you were following. And eventually you'll get to a single path that leads from all the information in the question it's it's a slow process to get confused. It is not a slow process to work through these questions logically. If you are trying to go through the question too quickly, what's going to happen is you're going to lose the thread of what you need, and you're going to misinterpret something or not be able to make a connection you need to because you're not defining everything for yourself. And that is, you have to get accuracy first. So if your accuracy is going to be getting the first 4 questions right and then not having time for the last 2, in every section, that's okay, because those are the hardest. That's okay, but you're aiming for accuracy first.
Don't be afraid to skip questions, because there's no extra points for hard questions, okay? If they just slow you down, you sink 2 or 3 minutes into a hard question, that is not the right call. There will be questions later on that are easier that you'll be able to do faster, and you're ruining your chances of getting those as well.
Yes, Mojo, we can do some practice stuff. Yeah, sometimes you'd understand. If you find... Yeah, Pocket Tees, that's right. Super high production budget. Yeah, we spent a lot of money on this. What, 6 shirts we bought? Something like that.
Mm-hmm.
Okay. Well, if you realize a minute and a half later, maybe do another passage and then come back to it. I'm not exactly sure what that thing is. Hopefully, by being very logically going through the questions, you are able to get to whatever realization you need first. Okay, so I'm...
Yes, it's just shirts.
CB Turtle, that makes... It couldn't possibly not make sense.
iCrush Dreams is here.
Yeah, iCrush is here.
It's been a while.
iCrush is pumped about the t-shirts.
Oh, iCrush.
Yeah.
We're pumped about you.
iCrush is one of the original viewers.
Are you still crushing dreams?
Whatever.
Hopefully you are.
Okay, so this is FIFA 123's question. It's in our Discord. That's probably the best. It is the best place to take a screenshot of a question you're working on your computer and post it there. Discord's down below or to the side, depending on what thing you're on. Okay, we have an art club, and an art club designed and made banners for the school colors, blue and white. So we have blue and white. I'm going to write those. We have blue and white. And it says that each banner required a quarter yard. So for one banner equals quarter yard of blue. Looks like everything is in yards, so I'm going to ignore yards because they're confusing for our brains. 1/4 yard of blue, and then we need 3/8 of white. Yes, maybe even 37. Yeah, CB Turtle got a 37 at some point, as I recall. Then was promptly arrested. The club originally planned to purchase exactly enough material to make 500 banners, but found the material to be cheaper if purchased in full bolts. And blue material 10. Okay, so 1 bolt. So there's a bolt. So, I don't want to write it this way. 1 blue bolt equals 10. I should put in these things. Let me know if anybody's confused right now. If you are, you should hopefully find this in Discord. This is a very confusing question for sure. And then 1 white bolt. I've never seen this question before, Braid, so make sure I'm doing it right.
Yeah, I've seen it a couple times.
And the white material in 12-yard bolts. Okay. And so they realize that they should purchase it in full bolts. So they're not going to get, and they want to make 500 banners. Okay. There are a lot of different things here. We have yards for lots of stuff, but then we also have banners, we have blue and white, and we have bolts. So there's a lot of stuff to keep track of. But I like writing it all out and not having it in sentence form. Stealthy Sumo, LCD, I don't know what's happening. LCD, never mind. Okay. Sorry. How many extra banners was the club able to make if they purchased enough full bolts to make at least 500 banners? Okay, so we're going to see how much is left over, at least common denominator. Oh, yeah, I see, okay, I see what maybe you're saying. I don't know if least common denominator matters for this question at all.
Only for the fraction stuff.
Yeah, it depends on how you go about it, I guess. Okay,
Keep going.
so we need to get to 500 banners, and we need a 1/4 yard of blue for every single banner. So that means to make 500 banners, we need how many yards of blue? So if we say that one banner, let's do this. So we have 500 banners, and we are going to use we're going to use unit conversion.
Yeah.
So 500 banners, and we need to get from banners to how many bolts well, let's see how many yards of blue we need first. So one banner requires a quarter yard of blue. So what I'm going to do is this stuff that maybe you've done in math and maybe you've done in chem.
You want to put banners on the bottom.
Yes, you're absolutely right. Okay. So we have... Just erase the whole thing. So we have a quarter yard of blue for one banner.
Put 500 banners over one.
Yeah, this is over one, technically. So we're starting with this, and we're using this conversion factor, which is technically equal to 1, because 1/4 yard of blue equals one banner. So from here, we multiply across. A quarter of 500 is 125. So we have 125 yards of blue that are needed. And then we're going to do the same thing with white. So we have 500. Also, FIFA123, I don't know who you are in chat. Maybe you're not in the chat. But let me know if this makes sense or you figured it out from now. So now we need 500 banners for the white, which is going to be 3/8 of a yard of white. Oh, that's you. Hey, JetBlue. Got it. 3/8 yard of white for one banner. Also, I didn't say this before, but the banners cancel out. That's the whole point of multiplying it by this conversion factor. And we have 3/8 of 500, which is what?
Calculator.
Yes. I should be able to do this in my head. My dad would be very disappointed in me, I think. Times 3 divided by 8.
187.5.
187.5. So 187.5 yards of white needed. There are a lot of steps to this problem. Wow.
Yeah.
Okay. Now we have to see how many bolts we need to buy, because we're going to buy enough bolts to cover this. So if you buy blue bolts in 10-yard increments, then that means that we need 13 of them. But what we're going to have left over is, so we're going to subtract 130. They're not asking how many bolts we're doing. They're asking, based on what the leftovers are, how many more banners we can make.
130 minus 125.
Yeah, yep, 130 minus 125. My bad. So this will be 5. We have 5 yards left over, so I'm going to circle that. And here it's the same process. So 12 goes into 180, I think, so we'll need 192. That'll be how many yards we'll get out of a certain number of bolts. I think it's something like 16 bolts. So this will be 4.5 yards left over. And now we need to see how many yards. So 5 yards, how many banners can we get out of 5 yards? So we're going to do the same thing. But we're going to go the opposite direction now if we're going to force this. So 5 yards of blue times, now we're flipping this. So now we have one banner over 1/4 yard. And that of blue. So these cancel. And then we have 5 divided by 1/4, which is 20. So we can make 20 banners with blue, but we need to go with the lowest common
Limiting reactant.
reactant.
Limiting agent. Or whatever.
Limiting whatever. We limit. So 4.5 yards of white. Yeah, this is definitely going to be the limiter. Of white. Multiply that by one banner over 3/8. Are you bored, Brady?
No, man, I'm just taking breaths.
Got it. Don't breathe, dude. That goes away. That goes away. 4.5 divided by 3/8 is 4.5 times 8/3. So 4.5 times 8 is 16, 18, 36 divided by 3 is 12. Maybe?
That sounds about right.
Yeah, 1.5 times 8 is 12. Yeah, okay. So 12. So we can make 20 with the blue and only 12 with the white, so 12. is our answer.
Limiting factor is what that's called. They do it in chemistry a
Limiting
lot. When you
Yeah.
got two reactants and different amounts of them, you're going to run out of one first, and then the reaction will be over at that point.
This is a wildly difficult problem. Well,
It's a lot of steps.
it's a lot of
You got
steps
to
that
keep
you have to keep
hold
track
of your
of.
units constantly.
Yeah. When you
Yeah.
start getting a lot of units and things like that, it's very likely going to be a unit conversion question, which is frustrating,
There
but
is.
I like how straightforward they can be. Does anybody have any questions on that? I'm going to check chat real quick.
We got to do Connor Meyer's question. Here, wait, go down a little bit more, and then we have to go up to Connor Meyer's question, because I think they put it in the chat.
Oh, I see what you're saying.
It's problem 57, so it makes sense to be hard. Yeah, all right, go up to...
You know what? I have the question. It was sent to me in a DM, actually.
Oh, was it?
Yes. And I asked them to not do it there.
Jeez.
So I can write up the question. It's too bad Brendan's not here.
Is it a constants and coefficients problem?
Yes.
He does like those. Well, what he doesn't know can't hurt him.
Yeah, don't tell Brendan, anybody.
Please
Everybody.
don't. It'll get very
Please.
personal very quickly.
Brendan's a personal guy.
He's very personal. Is it one we've seen before? Or just like this
Yeah,
type
it's
of it?
the mirror
Okay.
stuff.
Mirror, mirror on the wall. Something about me. Who is the most strong?
Who's the
Mojo.
strongest tutor?
Mojo. You are absolutely welcome. We do it because we like it.
Yeah.
Why do we do this?
I'm not allowed out of this black box, so I might as well do something.
Right. Actually, yeah, we've managed to finagle Levi's digestive system that he converts free tutoring into his own nourishment, which is why he does it. And it no longer works for him to eat, so he can only stay alive by tutoring for free.
Yep.
So this is kind of perfect for
So
him.
because the SAT and ACT are slowly being sort of phased out, I don't think they'll fully be phased out, but I'll get pretty hungry.
Yeah, you're going to be
I
pretty
think.
hungry. Yeah, definitely.
Yeah.
But thank you for watching Mojo123.
Yeah, I think I said this the other day, but we appreciate you watching us for free.
Yeah. Otherwise, we have to pay people to watch us.
Yes. Which we've
We
done,
don't
and
wanna do that.
it's hard.
It's hard for us. It's hard for them. Yeah, nobody wins.
Okay, this question was put in the chat a while ago, and I was the only one who got it in Discord because of DM. Yeah, Plaster Hippie, accept that. So this is what's given. We have 4x plus 4 quantity times ax minus 1. You want to do this one? Yeah, you do. Minus x squared plus 4. Minus x squared plus 4. And the question says, in the expression above, a is a constant, so a is a constant.
Which means it's not a variable, it's just a number, some number.
Yes. If the expression above is equivalent to bx, so equivalent, yeah, we'll get to that,
Yeah.
to bx, and b is a constant. So we're going to say b comma a
Is a constant.
is a constant. Right.
We love that.
And then we also know that that it's equivalent to bx. This thing is equivalent to bx. What does b equal?
Fantastic.
That's what we're looking for.
Fantastic.
So, Brady, what do you
Yes.
want to do with this stuff?
Well, first off, they tell us that this expression is equivalent to bx, which is just an invitation to say, this is equal to bx. It is an invitation. And I just accepted. I RSVP'd. I'm coming to the party. I'm setting it equal to bx, okay? It's great. So, next thing. I'm not really sure where this is going yet, but I know that there's some foiling we can do. So let's foil and let's just see what happens. So, we have 4ax squared minus 4x plus 4ax minus 4 minus x squared plus 4 is equal to bx. All right, we foiled. Let's now simplify and see if anything happens. So we have a minus 4 and a plus 4, so that's out of here. Those are going to cancel each other out. And the rest of this, I'm going to group the x squared terms and I'm going to group the x terms. So we have 4ax squared minus x squared, and then we have, I'm going to start with this one, plus 4ax minus 4x is equal to bx. All right, I want to just check my foiling went well. We have 4ax squared minus 4x plus 4ax minus 4. Good. Okay. Now, I'm going to, what am I going to do? Let's take a look at this. Levi, does it say for all values of x? Or we just assume so? Does it say for all values of x on the problem?
Dude, you can't just ask me that. You can't ask a tutor about
Oh,
that.
I totally can.
Okay.
And what are the answers as well?
That's a good point. It does not.
What are the answers?
The answers are -5, -3, 0, 12.
Okay.
So,
Okay.
Kayermeyer, when you, this question, is this from an official test? My guess is it's not. That's my guess. But let us know. If it is, then
We'll talk about it.
I don't like that.
Well,
But
yeah, we'll talk about it. All right. So here's what's going to happen here. It is from an official test. Here's what's going to happen. What you want to do is look at the symmetry of the situation. Okay. First thing I want to do is or is this asking us to do quadratic? I'm going to factor out an x squared here.
Yeah.
I'm going to find the coefficient, the full coefficient of x squared. That's going to be 4a minus 1. Okay? Does that make sense? X squared is in both these terms. We have 4a minus 1. That's in here. I'm going to factor out an x over here. So this is going to be 4a minus 4x is equal to bx. b equals 4x plus 4 times a minus 1, question mark? It might, we'll see. Okay. Oh, okay, here's what's going to happen. So if this works for all values of x, which is usually what you see, what that means is that you can set the left side equal to the right side. The reason for that is, let me show you a quick thing. Let's say I had this equation. 5x plus 3 is equal to 5x plus 3. How would you solve this? Well, you might say, let's subtract both sides by 3. Okay. That's going to be 5x is equal to 5x.
Divide by 5,
Let's
my lord.
divide by 5. Good idea, peasant. Divide by 5. X is equal to x. What do I do with that? What this means is that you have infinite solutions.
Well, you could technically do minus x on both sides. You get 0 equals 0.
Yes, you could do that as well. Yes. Okay. Fantastic. What this means, x equals x, is that you have any value of x possible would solve this. There's infinite solutions for all values of x. So this is true for all values of x. Is Levi copying me?
No. Also, it's very, very important. Kayermeyer's question here was not from an official test. If the official test has you do something like this, they will say one of these things or something to this
Kayermeyer
effect.
says it is.
Sorry, I don't know. Did I ask the question, is it
Yes.
a real test or is it not a real test?
I think, Kayermeyer, this is from an official test. You wrote that it is, right? I think so. We'll just let you answer this.
Yeah.
Anyway, if it's true for all values of x, that means that both sides are symmetrical, because any value of x could satisfy this. So what this means is that these two sides are also symmetrical, okay? We don't have an x squared term on the right side. So if we want to make this symmetrical, we're going to have to put in our own term. But because it's not there, we're going to just make it 0x squared plus bx. And then on this side, we have 4a minus 1x squared plus 4a minus 4 times x. So, if this is true for all values of x, these two sides are symmetrical. That means that these coefficients, the coefficient of the x squared on both sides will be equal, and then the coefficient of the x terms on both sides also have to be equal. Sorry, that should just be for the b. Okay? We can use this. Why wouldn't you on the third step just divide everything by x? Right here? Well, I mean, Levi did this just to show you something you could do, but there's a million different ways to go from here. If you divide both sides by x, you get 1 equals 1. If you subtract x from both sides, you get 0 equals 0. These are all signs that they're infinite solutions. 10 would work. 10 equals 10. So would 9. So any value would work here. Okay? That was just Levi showing you.
On the main problem.
On the main problem. Why would you divide everything by x? Oh, on this side, this part right here. Yeah, I suppose you could. Let's do that after I do what I'm about to do. Because yeah, you are right. You could do that. That's going to mean that 4a minus 1 is equal to 0. And that right here, we have 4a minus 4 is equal to b. Those are the two equations that I can pull out of this symmetry. So 4a would be equal to positive 1, because I added 1 to both sides. So a is going to be equal to 1/4. And now that I have that, I can plug it back into this equation to solve for b. we're going to have 4 times 1/4 minus 4 is equal to b, which is going to be, that's going to be positive 1 minus 4 is equal to b. Negative 3 will be equal to b. That's going to be negative 3. This marker's dying on me. Yeah, let's try this dividing by x, because everything has an x in it, we might as well. Now, just a reminder, if you divide everything by x, what you're getting rid of is a potential solution that x is 0. That doesn't really apply to this problem, but in other problems, like when you're factoring and you divide everything by x, you're getting rid of x equals 0 being a potential factor. Anyway, if we do that, we would have, this would be gone, this would be gone, and this would be gone. We get into the same exact situation. We have an x term and a constant, and we have a constant. So either way, we're just going to have to reset up this, and we're going to get the same symmetry. We're going to get an x term on both sides set equal to 0x, and then the constant equal to a constant, which will result in the same equations that we had here. Does this make sense? Levi, can you scroll down?
Oh, yeah, they're asking to explain the 0x squared.
No, on the main problem. It makes it easier, I think. Wait, explaining it with a 0x squared. I'm bringing minus 3 people to the party. You're bringing minus 3 people to the party? So you're taking people away? And there's a sad face. Is that the party when I invited people? Okay.
Yeah.
No, on the main problem. Mojo on the main problem.
That was talking
Oh,
about,
before.
Yeah.
Got it. Explain where the 0x squared comes in. Yes, okay, good question. Let me erase this for a sec, and let me give you a mini problem to explain that.
I'll erase this.
Okay.
Go on. Leave me behind.
Well, I'm going to have to use your space.
Right.
Very good.
Right. That doesn't make sense.
I'm going to use this space.
Okay. Got it now.
Okay. If we had something like this, ax squared plus bx is equal to 4x squared plus 3x, and this was true for all values of x, we could look at this and say, if these are symmetrical, then a would match with 4 and b would match with 3. So therefore, a would be equal to 4, b would be equal to 3. If this works for all values of x, then both of these sides have to be the same thing. That's what I was showing you before with 5x plus 3 is equal to 5x plus 3. If two sides are the same thing, all values of x will be possible. Solutions. That's what I meant by that. Okay? Let's imagine, though, that we didn't have an x squared term here. You can always put in 0 times something. It doesn't change the value of anything. We don't have an x squared term over here. So I need to make this symmetrical. I'm going to throw in my own 0x squared to make this symmetrical, and now I can show you that a must be 0 and b must be 3. That's where 0x squared came from, is because I have to match it with ax squared, and it wasn't there before. So if I just put in my own with a coefficient of 0, I'm okay. I can finally set a equal to something.
Right, and also, so technically this is a system of equations here. So if we had this, if you just ended up with this is probably not going to work very quickly.
Karameyer.
You got it? Okay, very good.
Very good. All right, should we get rid of this?
We should get rid of all of
There's
this.
so much.
Just get all of it gone.
Just destroy it.
Yep. If we just break the glass,
That'd be the end of Nerdish.
it would be the end.
Oh, jeez.
What have you done?
I got solution all over Wacom.
Nah, dude, don't worry about it.
Oh, jeez.
I'll tell Brandon no.
Well, no.
Oh, okay.
Don't do that.
What about all the money?
Look at all this. Look at this. This is so cool to
Yeah,
watch.
it's very
this.
cool.
Yeah.
It only works with the water. It doesn't work with a cleaning solution.
Oh, is it just water? There's no solution in there?
I've cut it with water a lot.
Oh, jeez.
We've had a problem about it. Whoa. Hey, also, keep asking questions. For those of you who are just watching, like we're super happy to have, you know, a 1-on or 2-on-1 tutoring session with Kayermeyer and have spectators, but definitely, you know, ask your own questions. We have a test link down below. I don't know what it is. 1572 CPRE. It's an ACT.
One of my favorite tests.
Yeah, one of the best tests ever, actually.
Actually, they've done studies.
Yep.
Yeah.
ESPN 8, the Ocho, actually did an expose on it
The Ocho.
a while back.
Dorothy Mantooth is a saint. Maybe quickly go through a few reading questions.
Oh,
You're forcing us to do it quickly? I mean, can we just do it slowly?
well, we're going to do it very slowly. Well, no,
What
we
time
probably
we
do
got?
need to do it
What
quickly.
time we got? We got 12 minutes left. Yeah, just pull up a couple reading questions, Levi. Levi's got you. What are the 5 Ds of dodgeball? Dodge, duck, dip, dive, and dodge.
Very good, Bird. Oh, wait, I can do this? No, I can't. That's not a good idea.
I'm gone. They can't see me.
That's not the case, Bird. They can
I know.
see.
I know. If you can dodge a wrench, you can dodge a ball.
Might be lagging, sorry.
Mojo says 16 in reading, like question 16.
Oh, you want to do number 16?
That's what Mojo wants to do. And CB Turtle would concur with that because CB Turtle just wants to quickly go through a few reading questions. So there's definitely an intersection of their wants with doing number 16.
Okay, so why don't you find the answer to this question for me so I don't, as I BS my way through it?
Okay.
Fresh eyes, please.
Yep. Okay, so we're going to do number 16 here. What's the best place to study?
It's a joke.
Is it?
No.
Wait, okay. SATs. The Kaplan is good. Wait, I didn't mean Kaplan. I meant Khan. Khan Academy is great. Don't go to Kaplan. That's dumb. I mean, do it. Whatever. We tutor 5 nights a week. Also, so right now it's cram sessions for the ACT because that's on Saturday. So, what do you guys do in a cram session on Thursday and Friday? We just stream for longer and we don't plan. So today, although we didn't actually do commas, but we generally plan math and then something else, and we lecture on that for the first half hour and only focus on those things, and then we just open up to questions. The cram sessions tomorrow and the next day are just going to be we're just coming up and we're doing 2.5 hours of streaming and ask whatever questions you want about anything. You haven't met Brendan yet necessarily, JetBlue, so you can ask personal life questions or questions about Brendan's personal life, which is just a mess. He's not here tonight, so we can say that. And you can, and so what I would recommend is doing a bunch of practice questions yourself, and then coming in with the ones that you need help on, or general approach type of things, or nerves type of things, or Brendan's personal life type of things. We also may be doing a raffle. I don't know if I necessarily want to yet, but we may be doing a free tutoring session or something like that. Raffling off a free tutoring session, something. Which, if you're going to take the ACT on Saturday, is not going to be that helpful, but going forward, Okay, what am I doing?
You're doing
this.
Number 16.
Right. So one of the main purposes of the last paragraph is to state that what? Okay, so here's the main thing. Main purpose, or purpose. This is a purpose question. So ideally, one, you've read the passage, or at least skimmed it. You can't wait. Yes, you can. You're going to wait right there. Don't move. Don't breathe. Don't think. Just repress and dissociate.
Love it.
Yep. Purpose question. You want to do this last. Yeah. Why? Can you scroll down? The chat is being dumb. That's annoying. Purpose questions should go last because rude. I apologize, JetBlue. And now it's not rude, so that's good. We are trying to figure out the purpose of the last paragraph specifically. Purpose questions, there are a couple things that are very important. Number one, they're not asking what. They're not asking what was said. They're not asking what the author is arguing. They are asking why. What is the point of what they said in this part? So the question here is not asking what do they say in the last paragraph. They're asking why do they say it. What is the purpose of that? How is it developing the passage as a whole? Which means that whatever their purpose is, whatever the answer is here, has to be in line with the rest of the passage. It may be the main purpose of the passage. It could actually be something opposing the purpose of the passage because they're giving some sort of alternative view that they then dispute, something like that. So, F, and so we're thinking purpose, not what happened. Gashes in the Rift Valley continue to increase in width. Have a good night, JetBlue. We will see you tomorrow. F doesn't help because that's not the point. We are talking about I think this is the seafloor one, right? And
Yeah, do you want to go back to the last paragraph?
Yeah, let's go back to the last paragraph.
Remember, is going to be really tough.
Yes, that's very true. Okay, so the last paragraph is down here. Yet what had seemed foreign to scientists is an integral part of Earth's very being. For at the ridge of our own planet gives birth. What?
Or at the ridge, our own planet gives birth.
For at the ridge, comma, our own planet gives birth. The floor of the Rift Valley is torn. So there are these big gashes. Here, the youngest, newest pieces of Earth are made. Great. Heat leaking up from the molten yada, 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 powering the volcanoes that deliver the ridge to the sea. Great. So this is how Earth is created. Let's go back to the answer choices. So we are trying. So they are saying this is what happens down there, and it's kind of cool sounding. So the seafloor of the Atlantic has cooled. No, that actually doesn't seem like it happened. Maybe I skipped it, but that's definitely not what this is about. They're not giving us specific geographical things that happened. This is a bigger picture thing, and we're asking why are they talking about it. So I don't like that it cooled. That's a little too small for me, and I'm not even sure that they said it. Gashes in the Rift Valley, I'm going back to F. Gashes in the Rift Valley continue to increase in width. No, again, we don't really care. This is a bigger idea than G, but I still don't like it. I'll leave it for now. H. The entire Atlantic seafloor has issued from the gashes in the Rift Valley. I like this one because in the paragraph itself, wow, I'm just pulling this out of my butt for sure.
Come on.
It is what it is. I like H because they are trying to. This is the last paragraph, and they're explaining the origin of the seafloor. And then J. Volcanoes on Earth's dry land. No, okay, so no, this is wrong because we have dry land and we don't care. So dry, no, it's not dry. Okay, so I like H. F is comparable, but again, we don't care about the Rift Valley. That's what I don't like. The Rift Valley is not so the purpose of this paragraph has to also be in line with the purpose of the passage as a whole, and we don't care about the Rift Valley specifically.
The Rift Valley is what the whole thing's about.
Nah. It's about that part, but the reason for this passage is about how the Rift Valley has created the Atlantic seafloor.
Yeah.
Like that's why they're saying this part. So it is in service of this bigger purpose. Does anybody have any questions on that? Who asked this? Plaster Hippie? Is this Plaster Hippie for number 16?
I think Mojo.
Mojo. I feel like it should be Mojo Jojo, but I'm sure that's taken.
I mean, the crossing out of the Rift Valley, I think, is not wise.
Makes sense. Cool. Well, okay, so maybe, if we're going to be...
It's wrong. No, the gashes don't continue to increase in width.
Oh, that's the problem?
It's just contradictory.
Okay, so it doesn't increase. That makes sense. Dude, you have to make me read the passage more closely. Yes. Okay, so Mojo. Why doesn't H get crossed out since it has Rift Valley too?
Yes.
That's a good point, because I crossed out the wrong thing in F. So Rift Valley is not the problem. That's what this passage is about. But F is contradictory to a fact in the passage. It's not still increasing, so F is wrong. It does talk about the Rift Valley. Yeah, we can go back to the thing. Where does it say it? What line?
Down here. It never says that the width of these gashes are increasing.
Yeah, it doesn't say that.
It just says that from the gashes come new seafloor. That's it.
Yeah, totally unsubstantiated. Okay. They are relatively subjective in a sense, but F is not subjective because this is an evidence-based test, ACT and SAT both. So you can't say increase. You can maybe assume increase. Maybe if there's a rift, it keeps growing. But it doesn't say it, so you can't make that logic. You can't make that jump. As soon as you start making jumps, you're getting closer to what Mojo thinks about this passage versus what the SAT or ACT people think about this passage, which, unfortunately for Mojo, matters more in this case. So do we read the passage first, or depends on your approach. Definitely don't do as little work as I just did. That's a terrible idea. There are a couple of options, but for sure you want to do the easier questions first, no matter what your approach. Do the vocab and context first. Do the questions that give you line numbers first and are smaller ideas. The detail-oriented questions are simpler. They require less understanding of the passage as a whole. Once you've done those and you've done more close reading of the passage, and therefore you can do these bigger ideas. So the purpose questions, the main idea questions, the inference questions, those are significantly harder. They require more understanding, which you've hopefully built up doing the simpler questions. So always do the simpler questions first. What the ACT does like to do sometimes is question number 1 for the passage will be, what's the main idea? Do not answer that. You can definitely get it right. It's not that it's going to be impossible to do, but there's no point in doing it because it might require more brain power than is necessary, and you are more likely to get caught up by a mistake.
So leave it till the end is what he's saying.
Yeah.
Main idea questions about the whole passage. You want to do all the other questions for that passage first, and then when you go back to that question, you will have thought a lot more about all the questions, and answering a question like that is easier.
Yeah. Or you could skip it entirely and never do it. And, you know.
Yeah, well, it depends. Try not to skip. I mean, don't leave anything blank, but skip things that'll take you a while. But once you're done with a certain passage, do those main idea questions.
Yeah. It does depend on their goal. If they want to do poorly on the test.
Sure, yes. Yeah. And it's assumed that we're not sure if they want to do well or not. We don't know if they're watching us because they want to do well, if they want to do poorly.
Well, on here, the kids who don't pay, I assume they want to do well, but my private students, I think they want to do poorly.
We'll see.
I generally give them bad.
This test, the reading section is not about memory. It's not about reading the whole section and trying to keep it all in your head like a sponge while you go through each of these questions. So, like, when you see a question like this and it asks you with the last paragraph, refresh yourself with the last paragraph. Don't try to just use your memory to eliminate options. Because everything is in that paragraph. It's all about finding textual evidence to back up your answers. Not about using the process of deductive reasoning with just your memory of the passage. You want to go back and really immerse yourself. Get your fingers in there. Just get them just dirty with the text.
Yeah.
Yes.
Thank you for the follow, Mojo. We appreciate it. Brady, you could feasibly read the whole passage. If you're a quick reader, awesome. Read the entire passage, go to the questions, answer the questions. If you are like me or like being very logical like Brady, neither of us do that. We both have different approaches. My approach, I'll explain first. One last question. Are you guys taking private lessons for Saturday? Feasibly, yeah. Not during the streams. So we're streaming 8 to 10:30 Eastern tomorrow and the next day. So we can't tutor then. But yeah, if you whisper or send us an email, you can follow our link. Our tutoring company is called Accelerate Tutoring, and that's where we do the private tutoring, and it's us and Brendan.
Link is to the bottom.
Hello, goodbye,
Scada.
I heard that you got kicked out. They rescinded your acceptance.
Is that true?
Yeah.
Why? What happened? What's Scada do?
I don't know.
Just for being
Probably hasn't been tuned into the stream
a general goon? Is that why?
Very much so.
No, they didn't do that. All right, see you, Scada.
Bye, Scada.
Yeah,
Bye, Scada.
Guys, tune in tomorrow. Keep asking us these questions. We can go over.
It's okay, Scada.
Scada, no.
I'm just kidding.
Make it into a happy bracket.
Yeah.
We feel bad now.
Put the colon on the other side of the parentheses where it always is supposed to go.
Yes.
It's actually grammatically incorrect because you don't have an independent clause after or before.
Before, right.
And you need a closing parentheses.
All right, Scott is getting a little better. He's not happy yet, but he's not
What is the name of that line, the vertical line?
Oh, jeez. I don't know.
Partition?
I don't know. I put it in things to make things look fancy. Like Brady Richter, vertical line, tutor, or something like that. But I don't know what that's called. That's a good question. Yes.
Okay, so my approach to we
should do it tomorrow. If you want to keep going, go for it.
No, we gotta talk about it. It's quick. We're not actually doing a question. Oh, we just got a minute. Yeah, that's probably who it is. Okay, great. Okay, real quick. We'll probably explain this again tomorrow. Yes, we got it. Thank you, Mojo. All right, so Bird, can you go to the passage and to the top of it? Hi, King Jason. You have decent timing. We're about to finish, but we're starting tomorrow again at 8 p.m., so you can tune in then or the next day. And then anytime after that, if you'd like. Okay, my approach to this passage, or to reading passages on the ACT and SAT, is I'm a really slow reader, so I cannot get through this whole passage and get through all the questions and finish in 35 minutes. I cannot do it because I'm too slow. What I do is I read until I know what's going on, and I jump. I skim, not for details, but for location of information. So when I'm reading this, I say, as the Kramer, and I read full sentences. I do. I read it until I get it. So as the Kramer idles through the Sargasso Sea. So we have the Kramer. I'm going to circle that. Seems like a boat because we're on the Sargasso Sea. Waiting for the wind to rise, the sea. Okay, so we're talking about the ocean. Great. I'm going to skip a couple lines. This vast and unroughened surface, yada, yada. Okay, so we're talking about the ocean here. And, and sweeping energies hidden below. Okay, that's an interesting little tidbit. Hidden below, I'm going to circle that. It seems a little ominous. Only 1,000 miles offshore, the Kramer has already sailed through some of Atlantic's most deepest waters. Also, I know this is a social science passage, so I'm keeping that in mind. So I'm going to go through, and I didn't read most of the words in this paragraph. I'm going to do the same thing for the rest of the passage. I'm just going to do it a little more here. So Atlantic's deepest waters like those, okay, so deep waters, unmarked plains of the abyss. Okay, so we're going abyss, we're going, I'm not going to circle Kramer again, flattened by layers of sediment, okay, rising foothills, seafloor, great, yada, 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 naval eventually, sailors more or less successfully calculated the depth. Okay, so they calculated the depth, maybe that's important. I don't even know where that is, so whatever. The crude sounding form basis, the first map of the Atlantic. Okay, so they made a map of... That's interesting. That's what I'm doing. I go through this whole passage in about a minute to a minute and a half, and then I go to the questions. So Brady, can you go to the questions real quick?
Yes.
Okay, so the first question I think is actually on the previous page.
Oh yeah, hold on.
Possibly.
There.
Or two of them. The author's attitude toward the main subject of the passage can be best described as, no, I'm not doing this one, because it's a general attitude about the passage as a whole. I don't understand the passage as a whole. I've just skimmed it for location of things. I'm going to skip this one. Now, number 12. The passage makes clear that Middle Ground, Telegraph Plateau, and Dolphin Rise were names that people gave to what was actually... Okay, so they've given these quotes. That means they're definitely here. They're right here. So they're in this paragraph. And I figured that anyway, because they were talking about the seafloor there and things there, which was in here. So I'm going to read this closely for the first time to try to answer number 12. Okay, I'm treating it like the science section. I'm only reading what I need to, and I skimmed it at first for location so that I don't get lost and I know where to go for every single question. And then I can come back to number 11 once I've done the more detail-oriented questions, the vocab and context, and did that one. Now, Brady, do you want to explain your way of doing it?
Sure.
Okay, so this is my way. Do not do this for the first time on Saturday if you're taking the ACT. That's a very, very bad idea if you've never done this before, because you need to be comfortable with whatever your approach is. Don't try something new on the test.
Okay, so my approach, I'm a little bit of a faster reader than Levi, but what I'm about to show you, I think works for people regardless of their reading speed, if they go to the questions first or if they go to the passage first. Here's what I do. First thing I do is I very quickly skim the questions to see if there's any line numbers mentioned. So right, 11 and 12, no. Next page, Levi.
Yeah.
What do I have? 13 in the first paragraph. Okay, so I have the first paragraph right there, so that's kind of what I'm talking about. No. 71 through 76, there we go. We got that. One of the members of the last, we got the last paragraph right there. Line 19 right here, and then according to the passage, not in range, according to the passage. Okay, great. Okay, so I have last passage, 19, 71 to 76, first paragraph. Levi, let's go back. What I do now is I put markings, vertical lines, next to the things that they were talking about. I have the first paragraph. I have line 19, I have 71 to 76, and I have the last paragraph. Okay? Now the reason I do this, here's where it gets fun, is because as soon as I finish reading one of these marked passages, I immediately go to that question. Okay? So I'm going to read the entire thing eventually, yes, but as soon as I'm done reading this first one, I know there's a question about the first paragraph, and I want to do it now, as opposed to reading the rest of it, going to that question, realizing, oh, it's asking about the first paragraph. I forgot what that's about. Let me reread it again. I'll get it right, but I'll have to reread it again, and that's the thing, is you don't want to have to reread things if you don't have to. It takes up too much time, okay? I'll do that question, come back, keep reading, bam, I read to this one, line 19, there's a question about that, let me go immediately do that question, come back, keep going, keep going, keep going, 71 to 76, do that question, last paragraph, do that question. I've already finished 4 of the questions by the time that I'm finished reading this, and I have only 6 more, basic subtraction, okay? This is a great strategy for me. It helps me speed things up without having to read the same things twice, and I think it generally helps most students, unless you have a very different approach. But I think that regardless of if you are a fast reader or a slow reader, this makes you not read things twice. Okay, it's well past our bedtime, so we're going to go. Please come back tomorrow, guys. Thank you for asking so many great questions. We are, as always, your humble, obedient servants, and we'll be here.
Very humble. Humble. Humble.
Humble.
Very good.